like now. If you can
Yeah,
change the
how do I
slide.
do that?
Yeah, I don't know. I guess you
Here,
press the arrow key.
I'll do it. Yeah, Justin, you do it.
That's fine.
Here we go.
Yeah, so hi, my name is Kenneth. If you want to follow me on Twitter, you have my handle there. It's Rhorohde with OH and not HO like everyone tries to use. So that's me. Next. Um, So I work at a company called Intel, and normally you won't associate us with browsers, but we do work a lot on browsers. And I myself is involved. I've been involved with WebKit since around 2006. So I've worked on browsers. I used to work for Nokia, so we did like mobile browsers. I worked on the team that did the first WebKit 2 based mobile browser before Apple. So that was pretty cool at that point. Since then, I moved to mostly working on Chrome and working on standards, mostly in the W3C, but lately also a bit on JavaScript itself. Next. So our team at Intel, well, there's multiple teams working on the web itself, but I'm in the web platform team. So basically, it is our responsibility to try to work on the platform itself, and there are like different reasons for that, but we're trying to keep the web open and relevant. So it means that if the web is there but no one cares about the web, it's not relevant any longer and it doesn't really matter. So we're investing in the web, and we do that by doing like feature implementations and also working on specifications. We also work on browsers themselves to add these features, and of course like optimize them so everything runs well on our hardware. Uh, so we also try just to look at what's going on in the web always, like identifying new trends, see where we can participate, and maybe enable it something like, let's say something like WebVR on a Chromebook. So any way we can help to basically bring the web forward is what we're concentrating on. Next. Next. Okay. So today we're going to talk about sensors. So I don't hope we, yeah. So you might wondering what are sensors good for? Well, you can group sensors in different groups. So we can talk about like motion sensors. These are for sensing speed, direction, and a state of rest. So you could imagine using these for like a game controller, for instance, for a maze game, maybe for tracking like a head-mounted display for VR and AR use cases, indoor mapping, photo stabilization or video stabilization as well. Next. There are also okay, it went back. Okay, so there are also environmental sensors. So this could be, for instance, something like a barometer, which can be used to, which is like an air pressure sensor, which can be used like figure out the altitude. So this actually exists in some phones. You also have a magnetometer, so which senses like a magnetic field next to it. So you can use that, for instance, as a switch. This is what they're using, for instance, on the Google Cardboard, the first versions. So basically, just moving a magnet as a button on your headset, and that actually worked as a button. So that was just using a magnetometer. Or you have like a light sensor. So for instance, at night you want the screen to turn dark, for instance, a map, etc. Next. So the starting point when we started looking at this is called generic sensors. So there was already support for sensors on the web. So we already had like geolocation. There was a way to get acceleration or device orientation. But all of these sensors work differently. They had different APIs. They were kind of high level. So if you really wanted to do something a bit more low level, a bit more customized, like it was really difficult. It's also based on like old API designs, because today we have like ECMAScript 2015 plus, we have promises, etc. But even worse than that, some of the features just like work differently on iOS and Android. Like you had to like, okay, now this is like 90 degrees off because I'm on iOS, so let me modify that. So that was like terrible user interface. Or like also like, oh, now it's using a magnetometer on one platform, on the other it isn't. Apart from that, it was not designed with security in mind. Next. So if you look at like the specific like these motion sensors, like there's the spec called device orientation and device motion, had like a lot of issues. It was based on like regular DOM events, so there's some limitations there. You could not configure them. For instance, if you want to say, yeah, I don't really need like 60 frames per second. I don't want to drain the battery. I just need like 20 or 10. You couldn't configure that. Um, and because of these like high level concepts, and it was not like super specified. It meant that like different platforms implement the features differently. There's also no timestamps, which is really important if you're going to do like manual fuses, sensor fusion, and they're like really difficult to extend. Um, Furthermore, like there were just like issues that could not be fixed, and the specification ended up being not maintained. Next. So if you look at the landscape, like there's more and more sensors in different devices. Like your phone, even your laptops have more and more sensors. Um, And smart devices, we have all those around us as well. And many of these, especially what we call edge devices, are usually just sensors, or at least they have sensors in them. So with new standards like Web Bluetooth, we can actually talk to these devices. So it would be nice to have like one API that kind of looked the same, whether these sensors were like remote or on your device itself. We also saw that people using Node.js use sensors. For instance, there's this project called Johnnyfy, which allows you to create IoT like experiences in JavaScript. So a lot of places we see sensors. Next. So the idea was basically to create like a new like really good API that we really thought about and like try to solve all these issues, but also like focus on simplicity and familiarity, so that if you know to work with one sensor, you can probably also work with another sensor. Um, it's designed for the web first and foremost, but like we also want to keep other use case in mind, like I said, like on Node.js, or if there's other places where people are using JavaScript today. So we don't want to tie things exactly into the DOM. Like it has to be a navigated or something because it might not exist in Node.js. And of course, we wanted to build these with security in mind. But the most important is we wanted to make it really, really easy to expose like new sensors quickly, because like creating a whole new spec and having to write all these details again and again, that takes a lot of work, and you end up making a lot of mistakes. So the way we kind of like went about this was to create like one spec that kind of like defines like everything that's shared, and then you create like this derivative spec which like just refers to the other one. So like only the things that you care about for that specific sensor. So that has been very important. Next. So this is from the spec itself. So it's like the goal of generic sensor API is to promote consistency across sensor APIs, enable advanced use case lengths to perform a low-level APIs, and increase the pace at which new sensors can be exposed to the web by simplifying the specification and implementation process. And I think that's really what we've done. Next. So this is the basic API. Usually in specs we use like WebIDL, but I assume that a lot of people are not that used to read WebIDL, so I just try to show it in TypeScript here. So a sensor, we have like this abstract interface called sensor, which like inherits from event target. It has like a few properties like activated, whether the sensor is actually running, has reading, whether it has a reading, and a timestamp, which is DOM high rest timestamp. And then it has like three different event handlers. So they have like you can attack them like directly, like it's like on reading equal to something, but you can also like add an event listener to reading, activate or error. And then you have like a start and a stop method. That's basically it. When you create such a sensor, you can give it options. I'll show that on the next slide. That's why we have like a shared option here called sensor option with the frequency. Next.
Kenneth, could you go over that last part again?
Oh
Past
yeah,
30
sure.
seconds.
So I said like that's why like when you create a sensor itself, like an instance, you can give it an option, like the frequency and things, like you see like sensor option here, but it's not shown on this slide. It will be shown on the next slide if you can change slide. So here you see one example. So this is the absolute and relative orientation sensors. So if you look at one, like you see that the constructor takes an options. So this is just like sensor options. Uh, and then they extend with a few extra things like This is an orientation sensor, so you can get a quaternion back, which is really useful for orientations. Or if you need to like populate like a DOM matrix because you're working with say CSS, then you have like this method called populate matrix. So you see that this is the only thing this spec basically does is like extend with a few methods. Next. So sensors, like you can group sensors in different groups. So we have these low-level sensors. These are like the accelerometer, the gyroscope, ambient light, and then you have like derivative sensors, like the linear acceleration sensor, which is derived from accelerometer readings. But then you also have some of these sensors which actually use data from multiple sensors, such as like the orientation sensor. And of course, you can have different types of those as well. Next. Life cycle is very simple. When you construct the idea, of course, with sensors, you might wonder like why I kind of just query why do I need to like instantiate and then call start? Well, the whole idea is that you shouldn't be able to like fingerprint depending on what sensor you have on your system. Um, so this means that like when you create a sensor, you can always do that whether you have that sensor or not. You'll figure that out whether it works when you call start. Um, and this is also depending on the options you give the sensor. So for instance, you say like, well, I want this sensor, but it needs to maybe get a frequency of 2000 and that's not possible. Well, then it will just fail. Um, so you have like different states internally, this idle, activating, and activated. So you see when you construct it, it's in the idle state. Then when you call start, it will go to activating. Maybe it fails and goes back to idle. If it doesn't fail, it will go to activated, and then if there's error or you call stop, it will go back to idle. Next. So there's also a lot of security threats on these different sensors. Like you could do location tracking, eavesdropping, try to measure keystrokes. Even just having like a cell phone next to your laptop, people have shown that you can just use an accelerometer to actually figure out what people are typing. Uh, because you can measure all the different readings, and you know that E is the most common key, and then after a while, using a dictionary, you can actually figure out exactly what people are typing. Um, Of course, there's also the device fingerprinting and ways to identify the users. So we're trying to um, handle these threats. Next. So some of the ways we're doing this is like ensuring that you have a secure context. So this like HTTPS. It only works with top-level browsing context. At least for now, we might like extend it if we have secure ways of doing that. If you lose focus, well, then you stop the sensors. You don't have the sensors running. So we look at visibility states, and there's also integration with the permission API. So the good thing is that this specification has actually been checked by security experts from Google, Intel, and also the W3C Technical Advisory Group. Next. So let's look at the motion sensors. So if you look at motion sensors, there's basically three common low-level sensors. This is the accelerometer, the gyroscope, and the magnetometer. So actually, the magnetometer is not really a motion sensor, but is often used together with motion sensors, which is why I group it here. Next. So the accelerometer is basically measures changes in acceleration, and it normally does that in three different directions. Um, it's also what is called like an inertial frame sensor. It means that if the device is like your phone is in free fall, the acceleration in the falling direction would actually be zero. This means that if you have it on the table, the acceleration will be in upward direction of like the gravity, like 9.8 meters per second squared. So this is kind of interesting. This is why you can isolate the gravity from an accelerometer. Next. So accelerometers are usually not that useful by themselves because like the data is really hard to use. So people often like they they do like derivatives, sensors, or they do fusion sensors together with others. So for instance, you could get like linear acceleration if you can isolate the gravity